So to prove we really know what we're talking about, we're going to use what we know about the linear regression model one more time in a different situation. This time we want to look at a researcher wanting to know about whether cola consumption is associated with lower bone mineral density in women. She collects data from a random sample of women. She asks the women how many colas they drink per week and then measured their bone density. Now we're looking at a different computer program output. This is Minitab output over on the left. Minitab is a software program. And I've also had Minitab draw a regression model with a trend line for us. All right, so let's answer some questions. What is the explanatory variable and what type is it? Well, the explanatory variable will be colas per week because that is along the x-axis for starters, right? And then that would be, it appears to be discrete and quantitative, obviously, because you know that if you drink more colas, you can perform meaningful calculations. Like 3 colas is one more than 2 colas. Now, why am I saying discrete? I know you're out there thinking I could drink half a can. Well, if you look at all of these dots, they're all in line with a vertical line of 0, 1, 2, 3, 4. So obviously they were not allowed to put in 2.5. No cheating. So you either drink 2 or you drink 3. So all these dots are in those. So it would be discrete. If they asked how many ounces per week, that would be more continuous. But in order to get a fair measurement of that, you would actually have to probably track people a little bit more than just asking them how many colas per week they drink. For example, we'd have no idea how big the colas are per week, and that information wasn't given. Now, something that is measured is the bone mineral density. That's very much measured. So that's not something you can take a guess about. So that would be quantitative continuous. So the colas per week is discrete because it's 1, 2, 3, or 4. The bone mineral density is measured, so it's continuous. Now, if this person wanted to measure, if this researcher wanted to measure the colas per week, say in ounces or milliliters or something like that, then that would be continuous. But just saying how many did you drink, that's discrete. All right, now what about the regression equation? Well, the regression equation is kind of hidden in this output up here. It's right here. Bone mineral density is our y value. We just said right here. So let me type that. So bone mineral density is y. Colas per week is x. That's what explanatory and response mean, right? Explanatory is your x, response is your y. So when you see bone mineral density, what you're seeing is y equals, and then they're writing it slightly differently. So let me type up what they write. Okay, so what the output does is say this, bone mineral density, but that's our y. And because it's a trend line, it's actually y hat. And then equals 0.8661 minus 0.002889, and colas per week is our x value. So I typed that up clear. So bone mineral density right here, that's y hat. Colas per week, that's x. So what they're really saying is y hat equals 0.8861 minus 0.002889x. That's a little weird for us because we're not quite used to going in that order, but that's perfectly fine, right? You can put the equation in that order. The other way you can write it, which is more familiar to us, is to reverse that order, to use the x one first. So let me just say or this other one. So really, any one of these 3 lines is correct. You could write it out with the words if you want. You can say bone mineral density equals 0.8861 minus 0.02889 colas per week. Or you could say y hat equals negative, 0.8861 minus 0.002889x. Or you can reverse it, which is this bottom right corner here. This is the one we're most familiar with, the one where we put the a and the x plus b. But it doesn't matter which order you go in. The slope doesn't change. The slope for all 3 of these is 0.002889. It has to be because the slope is always the one that's the number that's multiplied by your explanatory variable, which is x. So now we need to interpret that slope. All right, So we notice that the slope, again, is always multiplied by the x. A lot of people forget that. So it doesn't matter if it's in the back of the equation or the front of the equation. If it's multiplied by x, it's your slope. But we want to pay attention to the units because the units will really help us. So we want to say that slope is divided by 1. The 1 is in the x units, which for us is colas per week. I mean, it's really kind of obvious that the x unit would be colas per week. No problem. But the y is the bone density, which I have to go look it up. It's grams per centimeter squared. It says it right here on the y-axis right there for this. So grams per centimeter squared. And that's what we'll say, grams per centimeters squared. All right, great. Now how will that help us interpret? Well, remember, we'll use the ratio to write our phrase. So we'll say, if a woman increases her cola intake by 1 cola per week, we expect her bone density will decrease by 0.002889 grams per centimeter squared. There, and I just typed that up. So if a woman increases her cola consumption by 1 cola per week, that's the red part, the denominator part, and it's always 1 down there. Then we would expect her bone density. We expect it. I mean, this isn't lockstep. We're not an algebra class, but we expect it will decrease by about, her bone density will decrease by about 0.002889 grams per centimeter squared. Now notice I'm putting in some caveat language like about and expect. And also notice I didn't write the negative. I write the negative here when I say the word decrease or go down, right? That's how I say the negative part. Okay, so now what does it mean for the y-intercept? Well, the y-intercept actually does make sense in this context, unlike the life expectancy fertility one we just looked at recently. The y-intercept will be 0.8861. It's that number that's not with the x. There we have it. So the y-intercept is 0, 0.8861. And that says that if a woman consumes no colas per week, 0 colas per week, then we would expect that her bone density will be about 0.8861 grams per centimeter squared. Now again, notice we have some squishy caveat language there because this isn't perfect. This is just kind of an estimate of what we think is going to happen. I mean, look at the graph of it, right? So we're figuring out where the black line touches the y-axis, but that doesn't mean that the dots themselves were there. We had a couple women that did consume 0 colas per week and they were not at that value. All right. If a random woman joins the study and she says that she drinks 7 colas per week, what does the model predict would be her bone density? All right, so that's math teacher code again. I'm giving you an x value. I'm giving you that she drinks 7 colas per week. So 7 colas per week right there. And the model predicts her bone density to be, well, we're going to have to find it. So I'm giving you an x and I'm asking you for a y. Sticking with my color coding, right? X equals 7, y equals who knows? All right, so the equation was negative 0.0028889x plus 0.8861. Or just for fun, I'll go in reverse. So I'm going to go, let's think here. 0.8861 minus 0.002889 times 7, right? Because it doesn't really matter what order you have it in as long as you have the numbers correct. So 0.8861 minus 0.002889 times 7. And we get 0.865877. I don't know if I gave decimal places on this one. I didn't. So I'm just going to put it all in. And that would be grams per centimeters squared. Lovely. And I'm actually going to add in a part G here that I'm going to add to the notes for futures. So if the woman in part F's bone density was actually 0.875 grams per centimeter squared, find her residual and interpret the result. So the residual would be the actual, which is this value, minus the prediction, which is the value we found in part F. So let me type that up. Okay, so that would be the actual y, which was 0.875, minus the predicted y hat, which is 0.865877. So let me find that. 0.875 minus 0.865877. And we get 0.00913 or 9123. Now, what would the units for that be? Well, it would be the same units as the y values in our data set, which would be grams per centimeters squared. That would be the units for this. All right, great. Now, what does that mean for that person? So we should interpret this result. Does this mean that she has good bone density or weak bone density? Now keep in mind, bone density is something you want, right? You want to have strong bones. It helps especially with women for osteoporosis purposes, amongst other things. So we want her to have good bone density. So does she? And the answer is yes, she does. She's actually a little bit higher than we would have predicted based on her cola consumption, which is a good thing for her. There we go. So I typed up what I just said. So this woman has denser bones than we would expect by 0.009123 grams per centimeter squared for someone with her level of cola consumption. That's a good thing, as strong bones help combat osteoporosis, which I don't think I spelled right, and arthritis and other health issues. There, I fixed the spelling. Osteoporosis, porousness of your bones is what that's saying in Latin. So holes in your bones, right? And then arthritis and other health issues for women. There are health issues for men as well, but osteoporosis is particularly known for women.